She gave to Da Vinci?
That she what?
That she gave to Da Vinci?
Yeah. He thinks that she has a little smaller look that only he gets to see. Yeah, he thinks her and Da Vinci were what? Fooling around. And so he does not want the painting in his house, and Da Vinci gets to keep it until he dies. If you go to the Louvre, please realize that while you're standing in line to see Da Vinci, Mona Lisa, there's a beautiful painting out in the hallway that no one is standing in line to see that is a better Da Vinci. Okay? It's the Mary and the Rocks, where you got John the Baptist and her mom, his mom, and Mary and Christ, and John the Baptist is pointing at Christ, and then Christ is looking at the little cross that's on the side or whatever, and all this. And everybody just runs by it to get in line. So you might want to stop there as you go. All right, here we go. We have the original function. Y equals, or f of x equals, x to the fourth plus 4/3 x cubed. I'm about to show you how to use all that information I gave you. Minus 4x squared. Now, the first thing you want to do is take the derivative. Please don't find the x-intercepts first. I mean, don't do that. Take the derivative. That pen doesn't write well. Okay, take the derivative. F prime. I'm going to put F prime. No, just do Y prime. 4x cubed plus 4x squared minus 8x. Set the derivative equal to 0. 4x cubed plus 4x squared minus 8x equals 0. What am I trying to do here? I'm trying to find the what? Critical numbers. So if you're writing a little thing out here, what's the first thing you're going to do? Find critical numbers. First thing you want to do is find the critical numbers. Factor out 4x. X squared. Please do not throw the 4 away. It's important. Because if you're using this to do anything else with the problem, you're going to need that 4. And then 4x. And I hate to say this, but if you can't factor, you can't do anything. So just go ahead and give up. Now, after you do that and you find your critical numbers, does everyone agree one of the critical numbers is x equals 0, x equals -2, and x equals what? 1. Okay, after you find the critical numbers, skip down the page a little ways where you'll have room to put a graph under it. You're going to put the graph under what I'm about to write right here. You put f prime, and then you make a timeline. -2, 0, 1. Make a timeline for your f prime. You pick a number smaller than -2. Oh, and when you make the timeline, put little horizontal marks above those. Because you know that at those 3 x values, your graph has to be what? Horizontal. Is that okay? Right? Now, if you would have found that one of the critical numbers made it undefined, you wouldn't put a horizontal mark up there, you'd put a what? Vertical. Because if the derivative is undefined, you have what kind of graph at that moment? Vertical. Is everybody okay with why I put horizontals? That's just a little trick to help you on the really complicated ones. Pick a number smaller than -2. Don't you dare put it in here, folks. Put it in right here. What number do you want to pick? Okay, you're not working it out to an exact value. You're working it out to find out whether the result is positive or negative. -3. Negative, negative, -3. That means negative, negative, negative. So you get a negative, right? So it starts off going down. draw an arrow. You can put f is decreasing, or you can just put an arrow. But the original function is decreasing. Okay, we're using our f prime graph, and all f prime does is tell us what? Increasing or decreasing. Pick a number between -2 and 0. Negative, negative, but that would be positive, so you get a positive result, right? So between -2 and 0, the original function is not going down, the original function is going up. Pick a number between 0 and 1. 1/2. Positive, positive, negative. Multiply those together and you get a negative. Notice, I am using the information I gave you about the first derivative to make a chart of what the original is going to look like. Pick a number bigger than 1.
2.
Positive, 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 goes up. Somebody says, but Mr. Evans, why do you not pick like 5? Because it can only change directions after what? Critical numbers. That's the only place it can change directions, so you don't have to test anywhere else. Now, after you get that graph, we're going to go ahead and not, okay, -2, +1. Notice how I'm lining it up with that chart? See? Okay, I want to find out how low it went at -2. In other words, I know it came down here and it turned around and went back up, but I want to know how low it went at -2. Where do I put the -2 in to find out how low it went? Put it in the original. Now, there's a couple things you can do. You can put -2 in here and work it out. Or you can put -2 in and use synthetic substitution. Either one you want.
You plug in the original so you can get the y value?
That's right. Y values only. How do you find all y values? The original. Write that in your notes. Okay, so you get -2 to the 4th is going to be 16. And then that's going to be -8, so that's going to be -32 thirds. And -2 is going to be 4, it's -16. So you get -32 thirds. So way down here, there's a point that we know it has to go through at -2, comma, -32 thirds. Now, I want to find out where it's at when x equals 0. Put 0 in the original, and what do you find? 0. So it naturally goes through the origin. Then I know it turns around and it goes back down until x equals 1. And if I put 1 in there, I get 7. 1 plus 4 thirds minus 4. I get 7 thirds minus 12 thirds. Don't you dare have to pull out a calculator when you get to college. And I get 5 thirds, -5 thirds. So it's only down about that far. 1, -5 thirds. Now, I could probably go ahead and graph it from here. It's got to go down, right? Then it's got to turn around and come up, right? Then it's got to do what? Go down and then go back what? Up. And if you wanted to, you could go ahead and do a rough sketch of that. It won't hurt, but we're going to fine tune it. All right? But is everybody okay with what it's got to do so far? Does everybody know it's got to come down to here, turn around and go up to here, come down to here, and then do what? Go back up. Also know that when it gets to these, it has to be horizontal for just a moment, right? Everybody agree it's got to be horizontal? Could you guess? It's not going to come in there concave down, is it? Because it's going to be hard for it to be concave down and then be horizontal, right? Everybody get what I'm getting at? But in order to check this, we do the second derivative. And if you have to in your brain or with a light pencil, you can go ahead and put it down, up. But you're going to have to do concavity. So here we go. You go back to here. Take the second derivative. Y double prime equals 12x squared plus 8x minus 8. You set that second derivative equal to 0. I know you're going to factor out a 4. Please do not throw away these numbers out front, because if you start talking about the values and you want to know the exact value, those 4s are important, right? So you got to keep them there. And I'm hoping this is something that will factor. It's 3x, x, 2, and guess what? This one will not factor, so you'd have to use your quadratic formula, and you're going to find a negative one, and you're going to find a what? Positive one. But I don't think that factors, does it? Put a 2 here and a 1 there, it won't. Put a 2 here and a 1 there, and it won't. Okay, so I should have picked this one out, because I'm going to have to use the quadratic formula. When I use the quadratic formula, let's go ahead and take out the 4 again. Sorry. 4, we get 3x squared plus 2x minus 2 equals 0. Minus 2 plus or minus the square root. 2 squared is 4, minus 4 times a times c. Oh, and if you don't know the quadratic formula by now, and then 2 times 3 is 6. You'll get negative 2 plus or minus the square root of 4 plus 24, 28 over 6. Okay. 28 is 4 times 7, right? So that's negative 2 plus or minus 2 square roots of 7 over 6. Now, if you have to, you can see the one that's negative 2 minus that? That negative, oh. Then let's reduce that. So we're going to get negative 1 plus or minus the square root of 7 over 6. Folks, the negative 1 minus the square root of 7 over 6 is somewhere right in here. I know it's not bigger than it's not smaller than negative 2. What's the square root of 7 going to be? Is it the square root of 7 going to be 3? No. So you're going to get negative 4. It's going to be right in here. Is that all right? I want to know where to put it on my chart. Negative 1 minus square root of 7 over, somebody said it's supposed to be a 3 down there now, Evans. 3. Minus the square root of 3 over minus the square root of 7 over 3. And then there's going to be 1 somewhere right in here. It's going to be what? Negative 1 plus the square root of 7 over 3. Is that okay? And you can work that out to a decimal if you want to, and you'll know it's between 0 and 1. Trust me, it is. So, we're going to make a chart now with our second derivative. And the problem here is, first thing we're going to do is we're going to pick a number between these two. What's the easiest number to pick between those two?
0.
0.
Wouldn't that one be smaller than negative 2?
I don't think so.
Oh, wait. No, no, no.
You sure? You can double check me.
No, I don't think I was dividing by 3.
Okay. All right. Now, if you pick a number between them, what is the ultimate easy number to pick between them? 0. If you put 0 into the second derivative, does everybody agree you're going to get a negative? Right? Now you write the word frowns. Or you write concave down if you have to. Now, pick a number smaller than this number. We should have done this first, but I didn't want to. Pick negative 5, pick negative 10, pick something you know is what? Smaller.
How do you know it's frowning?
Because the second derivative is negative. When you put 0 in here, what do you get out? Negative. Okay? Put negative 10 in there. Does everybody agree that that's going to be, if you put a negative 10 in there, that's going to be a huge positive number, right? And then you're only going to be subtracting minus 88 from it. So if you put negative 10 in there, the second derivative is positive. If you put negative 3 in there, the second derivative is positive. It'd be a lot easier, yeah, if it factored, but it didn't. So it's going to do what? Smile. Now, pick a number bigger than 1 or bigger than 10. Pick a number bigger than that number out there that I wish wouldn't have been something that, we had to use quadratic formula for. Pick 5, pick 6. Well, if you put a 5 there, it's already positive, right? Is that okay? And do you know that's got to be positive because that's squared, right? Okay? So it's got to be doing what? Smiling. Now, what would you do if you wanted to know the exact y value where this occurred? You had to put this back into the original. I ain't doing that. Okay. It's going to decrease smiling. When it gets to negative 2, it's still going to be smiling. Is that okay? So it's going to decrease concaved up. Then it's going to start up, concaved up. And then when it gets to that value right there, it's going to just start concaving how? What's going to happen to the concavity at that point, right? Yeah, it's going to change. And then it's going to frown all the way over here until it gets to that value. Also, it's going to go up until it gets to 0, but when it gets to 0, it's going to start doing what? Going down. But when it's going down, it is still what? Frowning. And then when it gets to that value right there, it's going to quit frowning. It's going to start smiling, and it's going to smile forevermore. So those are your inflections. That's an inflection, that's an inflection. And you can see them lined up on the graph. If you will make your charts like this, and then put your XY graph under it and line up your numbers, this is not difficult. Okay? But that's how it works. But notice, when you do this, you want to make your chart right above where you're going to make your graph. Okay? Now, if I ask you any questions about this, you can answer them. Where is it concaved up? Any number less than that nasty irrational number that we got? Or any number greater than that other nasty irrational number we got. On what intervals is it increasing? Well, it increases from negative 2 to 0. It increases for anything what? Bigger than 1. Oh, where are our relative maximum and minimum? Negative 2 is a relative minimum. 0 is a relative maximum. Notice, the derivative equals 0, but the second derivative was negative, right? I told you that little chart, and yeah, there you go. It fits together. It's puzzle pieces, and I have shown you how to interpret the pieces. Tomorrow, I'll do a nasty graph. All right? Tomorrow, we'll graph something. I'll show you how this works if it's not pretty like that. We'll do, I got one here we're going to do. It's one of the ones where if you don't do the second derivative test, you'll get it wrong. Tomorrow's problem, and you can go ahead and write this one down, is going to be y equals x to the 2/3 minus 2x to the 1/3. Now, that's going to be tomorrow's problem, right there. And we'll show you how. But if you apply these rules and apply this approach, you can graph anything. Now, somebody's going to get into the rational expressions where you have to worry about the vertical and horizontal asymptotes. Hey, folks, that doesn't change any of these rules. It doesn't change any of this. All right? It just adds another layer to it, but it doesn't change anything. All right, I'm happy. You listen and you learn. I want you to look at what you cannot do from applications of the derivatives, and I want to teach it to you. I will teach you. Do y'all see I've used